Hello everyone and welcome back. In this video, we are going to talk about sequences where they contain factorial terms in their general expression. Okay, but before we do that, let's go ahead and review or recall what a factorial means. Let's do that really quickly. Now, what does factorial mean? What's the meaning of factorial 10? The meaning of factorial 10 here is that start from 10 and multiply all the numbers less than 10, including 10 until 1. Okay, so start from 10, go backwards. What's the number before 10? 9, right? We're working with whole numbers, so the successive numbers are in between a distance of 1. Okay, so you can subtract 1 and find the previous number. You can add 1 and find the next number. That's just simple mathematics, right? So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So these are the all numbers starting from 1 going backwards and up to 1. So multiply all of them. Okay, now how about factorial 5? So start from 5, go backwards. 5 times, 4 times, 3 times, 2 times 1. Now actually you can multiply them out, right? So let's see, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. So it's just one number. Factorial is just a one number which is written in a complicated, unusual notation like this, right? So I think 10 factorial, I'm not going to find that number, okay? This is going to be a huge multiplication. But anyway, now let's go back to variables. Now you have n factorial. So what does n factorial means? Same thing as 10 factorial and 5 factorial. Start from n and multiply backwards until 1. So what's the number before n? The number before n is you subtract 1, right? Remember that idea. We are working with whole numbers. The number before n is n minus 1. What's the number before n minus 1? Subtract another 1. That's n minus 2. What's the number before n minus 2? N minus 3. Now we cannot do this forever because we don't know what n is. So you multiply until 1. You can just write it like that. Okay. So simple as that. Now there's a one advantage with factorials, working with factorials. Here's a cool thing. Let's say you have to divide 10 factorial by 5 factorial. We can really simplify this really easily. What's 10 factorial? 10 factorial means 10 times, 9 times, 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. Should have choose a small number. 5 factorial is 5 times, 4 times, 3 times, 2 times 1. So I expanded out the factorials. Now look at what happens. 5 factorials, 5 times, 4 times, 3 times, 2 times 1 cancel out with what you have in the numerator, leaving this part, the part that I highlight from green color. Now if you multiply them out, you will get a 1 number. I'm not going to do that. I just now realized that I took a far too bigger number, but you can multiply them out and get the answer. So the idea is, if you have a factorial over factorial, you can expand them out and cancel out lot of terms and get a simplified answer, which will come handy when it comes to sequences. Alright, so now we recall what a factorial is. Let's go to examples of sequences. Okay, here's my first example. The sequence is n plus 1 factorial divided by n factorial. Let's say the n values are going from 1 to infinity. Now if you want to know the convergence or divergence of the sequence, you have to find the limit. So let's find the limit. Limit when n goes to infinity, n plus 1 factorial divided by n factorial. Nice. Now how do you find the limit here? Use the trick that I showed you just a minute ago. Okay, expand out these factorials. But before you do that, just pause a minute and look at this sequence and see. Now there's numerator and denominator. Who's larger? Who contains the larger number? Numerator contains the larger number, right? N plus 1 is greater than n. So remember that, okay? Right, so what's n plus 1 factorial? We can expand it out. So the limit when n goes to infinity, n plus 1 factorial means start from n plus 1, multiply backwards until you meet 1. So the number before n plus 1 is subtract 1 from n plus 1, right? That's n. Now the number before n is n minus 1. So you do that until you meet 1. Okay, don't worry about what happened in the middle. What's n factorial? Start from n and multiply backwards. So the number before n is n minus 1, the number before n minus 1 is n minus 2, and go until 1. Now guess what? What's going to happen? So in the numerator, you have n factorial hidden here, right? N plus 1 factorial can be thought as n plus 1 times n factorial, or you have n times n minus 1 times all the numbers before n in the numerator, and that's exactly what you have in the denominator as well. So these two numbers cancel out, all of them cancels out, right? So what are we going to left with? Just n plus 1. In the numerator, you left it n plus 1. In the numerator, when you cancel out everything, it's 1. So now what's the limit of n plus 1 when n goes to infinity? When n gets large, n plus 1 gets large too. So the limit is infinity. So then this sequence is divergent. Okay, here's a quick exercise. How about if you flip this sequence? So let's say you want to find the limit of the sequence. Let's say now the sequence is n factorial over n plus 1 factorial. What do you think will happen? Again, n factorial in the numerator. Now we'll cancel out with n factorial in the denominator, right? Do that simplification by yourself. Okay, so what we're going to left is 1 in the numerator. In the denominator, you will leave with n plus 1, just like here, but the opposite. Now see what happens. Now this is a different example. Okay, I'm generating a new example here. So when n gets large, denominator gets large, that means the entire fraction gets small, goes to zeros, right? So the limit 0. Now in this case, this sequence is convergent because 0 is a real number. Cool, right? You flip the fraction, all of a sudden you get a convergent sequence. All right. Now let's look at another example. Let's make it a little bit more interesting. Now I'm going to do another 2 examples apart from this example that I'm going to give you. Those 2 final examples will be really interesting. Okay, right, now the sequence is 2n minus 1 factorial over 2n plus 1 factorial. Okay, now my suggestion for you is pause the video and solve this problem. Give it a try, simplify. Okay, I think you tried it. I hope you tried it. Now what's the bigger number? I think the bigger number is the denominator, right? Because 2n plus 1 is larger than 2n minus 1. Now you want to take the limit. Okay, right. Guess what? What's the limit is? It's going to be 0, right? Let's see it for ourselves. Now 2n minus 1 factorial, if you expand it, you start from 2n minus 1. Now what's the number before 2n minus 1? You subtract another 1, right? 2n minus 2. What's the number before 2n minus 2? 2n minus 3, right? You subtract another 1. And likewise, you go until 1. Right. Now in the denominator, you start from 2n plus 1. So what's the number before 2n plus 1? Subtract a 1, right? So when you subtract a 1, this one cancel out. So it's going to be 2n. Now what's the number before 2n? 2n minus 1. Okay. And this goes on until you meet 1. Okay. Now what do you cancel? You can see in the denominator you have 2n minus 1, and starting from there going backwards all the way up to 1. And in the numerator also, that's exactly what you have. You start from 2n minus 1 and you go all the way back up to 1. So you will cancel out this entire section, and what you leave with is 1 over limit of 1 over 2n plus 1 on the denominator and a 2n on the denominator. Now this time we are left with 2 terms in the denominator. What's the limit? Well, when n gets large, denominator gets large, overall fraction gets small. So the limit will be 0, right? So this sequence is also convergent. Nice. Now I'm going to give you a whole new different example where hopefully you can learn something new also. The example sequence is, think about the sequence 3 to the n over n factorial, where n values are going from 1 to infinity. Okay, now again you have to take the limit to decide whether this is convergent or divergent. Now here the simplifying or writing out what n factorial means won't help you. Expanding it won't help you, because 3 to the power n will not help you to cancel out certain terms. So what can we do here? Now to solve this problem, I have to give you a cool fact. Here's a fact. N factorial will be always powerful than nth power of any constant. Okay, so this is very important. Now here's what happens. N goes to infinity. We are talking about n goes to infinity. That means n gets large. That means n grows. Now here's a fact. When n gets really large, factorial n is very powerful, okay, or goes to infinity faster than power of n over any constant. So here in the numerator we have a power of n of a constant because base is 3 is a constant, and you have n factorial in the denominator. So if you compare both of them, n factorial is powerful, grows faster. Grows faster means n factorial will go to infinity really quickly before 3n, okay, 3 to the power n. That means what's the limit of this sequence? Now this means n factorial grows really fast, okay, grows really large. So the denominator comparably grows really large faster than 3 to the n. So the entire fraction will goes to 0, okay. So the limit will be 0. Remember, denominator, when denominator gets large, the fraction will get small, okay. Now here I know the numerator is also increasing. I know that. But the idea is, even though numerator increase, denominator increases faster than numerator. It's like a race, okay? You can think of a turtle and a rabbit in a race. The rabbit will run fast and go to the destination much earlier than the turtle, okay? I'm just making it up. That's what I would expect to happen, okay? But anyway, so that's the idea. Now here I only talked about n factorial and a term where a constant is the base, okay, and the power is n. However, this fact change if you have n in the base as well. Like if you talk about n to the power n. Now when you compare n to the power n and n factorial, n to the power n will now grow faster than n factorial, okay. So n to the power n is powerful than n factorial. But in all the other cases, n factorial is powerful when you have a constant base, okay. Right, now why this happens, we can see this. Now n factorial is actually n times n minus 1 times so and so on up to 1, right? But n to the n means n times n multiplied by n times itself n times, right? Now if you compare these, n is n, which is same term by term, n is greater than n minus 1. So each term of n factorial is either smaller than or equal to n to the power n, each term of n to the power n. Because of that, n to the power n is larger than n factorial when n gets really large, okay, when n increases, when n grows. So these are two facts that will be helpful when you are taking limits of terms of functions involving factorials and exponential. So you need to figure out who grows faster than who when n gets large, okay. All right, so hopefully you learned something new from this video. In the next video we are going to learn about sequences, another different type of sequences, okay. All right, so I'll catch you there. Thank you very much.